The Blackberry series of devices have become amazingly popular to a certain population, because they were the first technology to really offer an integrated device and infrastructure of communication. And because, at least I've heard, I've never used them, they're very easy to use. They're supposed to be very cool devices, and they're used in various fields in big companies, and they're very popular in governments all over the world. He just complained that I'm doing his talk. But the thing is that not much is known of the technology involved, because it's all proprietary. And tonight we're going to hear some of that, and FX and FTR of PhenoElite are going to shed some light into what has until now been unknown to most of the population. Give it up for FX and FTR.
So, hello, and thanks for staying here and not driving home like everyone else. It's the shittiest spot I ever had, but I appreciate that you took the time and actually want to listen to this. So we're talking about Blackberries. I wanted to add a little bit stuff in front of it. This is actually not easy. Getting into an entire infrastructure thing that nobody actually knows anything about it is fairly hard, and you can do it alone, but it works a lot better if people help you. And we had a lot of support from very few but very important people while breaking it, and then while dealing with the results of breaking it. So this talk is actually dedicated to those people, and various political reasons prevent me from naming them. So the purpose is, not to be gloomy, but to actually have fun with the devices and with everything else concerning Blackberries. So we want to give a starting point. Basically, this is why it is called to arms. We basically want to give an overview of what's there, what's been tried, where did we fail, and we failed a lot. And basically, to give you an idea, and if you're either a hardware hacker or a Windows hacker or a protocol reverse engineer or whatever you do, to identify where your field applies and if that looks like fun to you or not. So it's up to you where you take it from here. Oops. So this is what we're talking about. Basically, that's RIM's version. That's what you can download off their websites. At one side, you have a lot of features that the guy who introduced us just talked about. And on the other side, you have what management usually calls crackberries, because they make addictive. Sitting here and talking over a range of wireless networks, then over the internet, through this admittedly very thin corporate firewall, and then into a corporate network and talking to important things like application servers, web application servers, and whatnot. So this was the big picture, and now we basically spend the next hour showing you smaller pictures. And FDR is going to start with the network protocol side.
Okay, the network protocols overall. Within Blackberry found many different protocol layers and protocols implemented. We just had a glimpse on a few of those. We actually will go for the network architecture. We'll have a look into SRP, whatever that means, and the other protocols as named right here. Let's get into the network architecture, which is a more simpler picture than the original RIM picture. Every company gets its own BES that talks to the RIM internal server, which is then relaying the packages out to the devices. The link we focused most on is the communication layer between the BES, between the BES and the RIM external server, because that was the communication layer which was hyped most. in Presscom. We just want to get into it and we want to see what messages look like and what the content is and who's going to read these messages or not. Okay, the communication layer there between the BES and the RIM internal server actually stays on IPv4. And in IPv4 we get a payload which is basically SRP, the protocol they use to name server relay protocol. Depending on where you Google for, you find a different explanation of what the name is. The protocol itself is fairly simple. It got a small header and it got different chunks of where the data are stored in. The chunks themselves looks more or less like this. You have two different types of data which can be.
Use this laser pointer.
Green. Cool.
It's much brighter.
Much brighter. It's a blowtorch. I like those. Okay. Back to the topic. The data chunks themselves have two different kinds of. Either they're integer chunks, which are identified by 049 and 49 hex, which translates to a capital I in ASCII, and strings are transmitted as with the tag field 53 in hex, and then after that we get the length and the content. And it took us a while. We just read the hex terms, and later we figured out that 53 is string and 49 is integer, and it just the basic layout of the SRP protocol. In the header, we got these function names, and we got tons of different functions implemented there. Most interesting might be config. The one we had to play with most is data, because that's the one used for transferring the messages later on. So there's a lot of playground left for our fellows of that talk, you know. Basically, we have been able to implement a fake server and a fake client in Perl to communicate either to the RIM server on the RIM side, or to implement the RIM server in order to fake that server to the local BES. Therefore, you need that kind of session setup. Kind of interesting is that the random values down here are just needed once, and so you can just sniff it and take them again and again and again. You just have to take care of the fact that the random seed and the random value have to match. And everything else is as it's laid out here. Inside the SRP, the message itself is transmitted in a protocol layer that's called GME. We found that in the binary, the acronym. We assume it might be generic message encapsulation, but we are not sure about that. And it's used actually for, as I said, to transfer the message from the enterprise server down to the RIM internal side and then onto the device. It's like a simple routing information in the header, which is source, destination, message ID, stuff like that. The general layout of the GME is like this. You have source. It's again a TLV, tag length value protocol. Important is that the source is 10, destination is 20, and application identifier is 50. And you see there's a gap of 30 and 40, and there might be other fields which we haven't seen yet inside the protocol. Important is what I found kind of interesting is that the header is terminated by a 0 byte, which is not like a 0 bit. I don't know what 0 byte, which is against the rule of a typical tag length value protocol. So we couldn't figure out why they interchanged so different protocol styles. On the one hand, they use tag length value protocols in different kinds, and then they use fixed size fields and 0 byte as terminator for these fields. Inside the GME, inside the GME payload, we have the application layer. There are different types of application layers. We have CMIME, CICAL, then IT admin, and lots more different stuff. The one we have focused most on is CMIME because that's the one messages are used. That's the one used for transferring messages. What's very important in here is the fact that those PIN messages are transmitted in clear text, even if claimed otherwise everything is encrypted. If you send a message out from the BES to the device with the PIN as destination, it goes over the air in clear text and everyone can read it. It's not really documented on RIM side, but it's documented in the wild. If you know it's there, you can find it.
It actually is documented on a RIM site. If you know exactly what to Google for, you find a document. Interesting enough, there very little documentation and actually very little communication in the developer forums. But this is actually a point that people writing code for Blackberry are pointing out very regularly in web forums. They will basically repeat and repeat and repeatedly say, if you send PIN messages with the API, it's going to be clear text. Yeah, but to actually find it on RIM's website, you have to know the exact term or the exact phrase to Google for to actually find a document.
Okay, the basic CMIME format is as follows. We have at the beginning the encryption type for the legal encrypted messages. Then you got the session key, we got the key ID, which is then terminated by a 0 byte, which is again not tag length value against all other protocols they use. Then the session key, then a terminator, then the message identifier, and then the encrypted message. The application layer is from here down here, and as I already said, the encryption could be either AES or triple DES. We found those documented all over. Then the key ID itself is sent over the air in clear text again. Session key is encrypted with the device key, and that session key is used later on to encrypt the whole message. 2 words about the crypto. First of all, we aren't any crypto people. We don't know shit about crypto. So we just can say the library used to implement the crypto is FIPS certified, so should be okay. The assembly itself looks also quite okay, so we haven't seen anything there. But Rüdiger Weiss might have a look at the crypto library later on, and maybe he can figure out if there's any special in which is not usual. Putting all these things together, that's a message as it is transmitted over the layer.
Ist der Ron hier im Saal? Ist nicht in Saal 1.
Bastard. Okay, putting all these things together, the whole message packet looks like this as described here. Starting with the SAP layer, version, that's the data field. Then we have the length of the whole packet, the SAP message number. Then we come into the GME. We have again version number, detect the length. Then we have the documentation of the source and the destination. Then we have down here the key number, and then we get the encrypted session key, and after all the final message, and then some SRP trailer. Since those CMA and since those source and destination are clear text, you can perform traffic analysis on the traffic as with any mail transport layer in the world. So if you are able to intercept incoming and outgoing traffic into a company, you might be able to spot which email address belongs to which device. Since you just send in an email to John Doe, see what SRP message goes out to which device ID, and then you can figure out that this device ID should be related to John Doe. And later on, you can figure out that manager got that device ID, and if the traffic increases for that manager, you might know there's something strange going on in that company. Let's come to the point where we can say what we found in those protocols. First of all, the SRP itself, whenever you connect to those RIM environment, you can use the SRP session key, which is not seen as a secret for most of the people, and they just provide it on the web pages. You just Google for it. And if you use that key and connect to RIM and say, here, I'm the one using that session key, what happens next? His session gets dropped. He cannot log on anymore for a long time, and RIM does not know about it, and his email service is out of service for a while.
So the thing about this key is, and I think we're going to show it later, it looks like a license key. And what happens to a Windows administrator that gets a long list of character, dash character, number, dash character thingy, and needs to enter that in the setup dialog? Well, it looks like a product license key. It's a sticker on the CD, like with Office or your arbitrary porn reader or whatever. So basically, they think it's a license key, and therefore, it's not perceived as a secret, while at the same time, it's actually their only way to authenticate that they are who they are against RIM, which is an interesting, interesting in terms of perception. If it would be clearer that this is a password or a very important value, people wouldn't put slides on it.
In addition to that, in the config dialogues from the enterprise server, you even see these keys in clear text, and that doesn't even help to get people into the information that is high value information and you shouldn't share it. The next thing we found with this SRP string tag, we got this 53 tagged SRP field. The length field there got a little integer problem. The one thing is, if you put a too big number in, the process just dies. So you might be able to and somehow crash those processes. And the other option is, if you put a value of -5 into that field, the process runs forever and loops and loops and loops and loops and loops. The interesting thing is what we found out, that any process we've seen on site on the BES enterprise server is using the same implementation and is looping all the time. The question would be now if that happens also on RIM side, if you send a packet to RIM. And if you send a multiple packet to RIM, maybe all of their processes go in loops. And
which we didn't try.
So, and all their processes going in loops and not coming back. So they might be out of business for quite a while and never figuring out why.
Apparently that's not the case. According to testing done at RIM's side, that's not the case. And actually, even we hope that they're right.
Okay, the next thing within this SRP protocol, since we have shown that the pin messages go out in clear text, you can use those to send messages you can use those to test if you can send a message to any other device in the world. We did that and we succeeded. Basically, what this says is that you can send out from 2, and you can get to send out the message to all Blackberries in the world. And that's kind of interesting because, you know, these Blackberries are used by managers, and these are interesting people to send spam to.
Talk about targeted marketing.
Okay, the last thing I can talk about is the over-the-air stuff. Actually, we can't talk about since we haven't seen it and we couldn't touch it. And it's actually not our home ground, so we haven't played with that. If anyone in the audience wants to, he's happy welcome. But it should at least contain the GME layer again, because that's ending up on the device side. And we leave that for the audience. Yeah, that's it from my side. FX is going on with the devices and the infrastructure stuff. I send you the science of power.
Muss ich jetzt meinen
Science of power.
too short. Okay, the devices. Neat little devices, everyone loves them. I actually started hating them really bad. Oh my god, this is a weapon. So they're actually fairly interesting. But it's, yeah, let's talk about the history first, because that comes in later, really interesting. And when you start looking at something that's well established and been done for a while, you start to look where they come from. And so we did that, and they actually were introduced as a pager service in the days when pager services were a cool thing. I do remember having a Skyper or something, quick thingy. So that's the time they came from. They originally ran on Intel CPUs, which is really cool because, you know, we all know Intel and all the tools work on Intel, and we can do everything with Intel. And they had a real-time OS with a support for third-party binary modules. With a lot of Google magic, you actually find very, very obscure 16 or 32-bit code that's in, yeah, it looks really old, and it actually is really old, like some of the 90s. And it's supposed to be loaded on a Blackberry. But it took a while to figure out that it's supposed to be loaded on this historic thingy and not on the stuff that we actually had, like those. Was macht er eigentlich hier? Okay, hardware today. First of all, thanks to Frank for, you know, taking the clothes off. It's an ARM7, like in almost all embedded devices that you carry around. It got partially thumb code on it, which is interesting because it doesn't look like they wanted it this way, but it's actually doing some thumb. Got a built-in DSP, separate codec chips, 64 meg flash, 32 meg RAM, 4 MB SRAM. Basically how it looks like is this. It's a pretty decent piece of hardware. That's what you can say. The interesting part, of course, is on the backside we got like tons of connectors, and well, as much as we are not crypto people, we are also not hardware people. So when I touch hardware, it usually starts smoking. So we didn't really try it out in the Datenschleuder that you got, like this publication. There's an audit version of this, and yeah, if you're bored and you got a multimeter and you're more talented with hardware than I am, just try it out and see what it talks there. The OS architecture is really interesting. On the 7290 that we played with, we actually found a CADEC AMX4 kernel. This is a commercial real-time operating system. There are many of them out there, and they've really never been really audited. So it's a green land for everyone who likes reverse engineering. So it's a CADEC kernel. Supposedly newer devices actually run other kernels, but we only checked on a 7290. It's the most widely used here in Germany. The code for handling, and this is interesting for the GSM security people, the code handling GPRS, CDMA, and all the other protocols is, of course, residing in binary space, which means in kernel space, which means if you're talking to a BTS in a GSM network that's not too friendly to your device, there's a very high likelihood that you can actually exploit something. And still, these binary modules that I talked about, they're still used. Interesting is the way they're actually made, because that tells you about how much you get from them. They're actually DLL files, like on your Windows machine. So they're PECOF DLL files, and they're just linked against the RIM operating system and not against your Windows operating system. And they actually have ARM code instead of Intel code, but other than that, it's like a DLL. And they're still there. One of the DLLs is the JVM. The JVM is actually the biggest binary module, and I think the only one intentionally loaded so far on a Blackberry. So it is a signed binary, and the Java version we really don't know. The Java vendor is actually RIM, so it's not a licensed VM, which means a lot of code that they reinvented and that might be broken. Unfortunately, they actually didn't implement the full J2ME classes. For example, the reflection API doesn't work. The reason for that is, or it's actually just not there. The reason for that is that all the binaries, all the Java applets that you're supposed to put on there need to be digitally signed. And of course, you could just use the reflection API and load not signed code into the device. So out of sheer cleverness, they just took it out. It's really a pity when you get a cool idea and then figure out the classes are not there. Device control is via RIM classes, and to use the RIM classes, you need to have signed code. Now, this code signing is really interesting, but in between, there is another thing. This slide order sucks, but anyway. You have IT policies. IT policies are basically something that your administrator can send down to your device and basically set permissions for you or things that you're not supposed to do, like run someone else's code or use pin messaging. So a cool thing, by the way, is like turn off pin messaging for all the devices when you roll it out. So everyone who's implementing BlackBerry on a large scale actually uses those policies and must use them because the default settings are a bit too open. So here's the code signing deal. To actually get RIM classes to work on a real device, you have to get a signature from RIM. What they sign is, they sign a hash of the JVM binary, which is SHA-1, I think. Now, to do that, you have to pay $100 once to RIM, and basically, this is a way of authenticating you, and you have to fill out a huge form saying what company you work for and stuff. Basically, but that's the only cost you have. And then, well, you send in the binary and you have your user account and you can, the hash, and you have a user account and you can get the hash signed and then everything works. The suspicion here is that the idea is actually that they have a collection of hashes from every single binary that's ever been run on a BlackBerry, just in case that one of them turns out, hoo-hoo, I'm a virus. And they then know who wrote it because he paid for the account, which of course works in a world where nobody loses or gets stolen his credit card. But, well, not in this one. Unfortunately, Lisa tried something really, really cool, and unfortunately it didn't work, was replacing the class loader. I loved the idea, and then again, it didn't work because it's loaded somewhere, it's checked somewhere else, so it's not in the Java space. The firmware images themselves also have a signature, and it's checked in a loader, and unfortunately also in a device. The loader is a Windows program, so it's really easy to convince the loader that your signature is cool. But the device actually checks that from ROM as well. There was a discussion I wanted to show the disassembly about the loader because it's a showcase in how easy cracking can be, like a beginner level if you want to get into cracking. But that didn't pan out for various political reasons. So this is the sequence of keys you need to press in IDA once you loaded loader.exe. That's all you have to do. You switch two strings, search for a signature, press enter twice, cross-reference, there. You will see a conditional jump, and this has to go away. So the next idea what we had was curing this coffee addiction of the device, meaning no Java, please. The loader actually still supports a lot of interesting features, one of them being a command line switch saying no JVM. This causes a firmware load that does not contain the Java virtual machine, so you get the naked operating system. It looks surprisingly like a 90s Nokia, or just like a pager, so it's back to mama mode. And then you, of course, have no JVM to talk to. The idea is to get other binary modules besides the JVM potentially on the device, which would then allow you to use the C API from the old pagers, which is really cool because you're basically, painting around pointers in kernel space of a crypto device. So, of course, the crypto doesn't get you anything anymore. We haven't actually got this to work due to time constraints and everything else. The idea is actually to have a DLL with stub functions. You know the C API because it's documented. So you can create a file that basically exports all those functions and just says return 0. Because all you need is the name rim.os and your DLL linked to. And then you link this, or you create this by hand if you're really bored. And then make an ARM DLL with the embedded Visual Studio from Microsoft, which is for Windows CE, but creates ARM code DLLs. And then all you basically should need to do is create a description file and load the DLL onto the device. Now, we've heard that supposedly all binary modules are checked, and the signature on the DLL is as well. But as long as you don't try it out, nobody knows. So we had this talk, I think, 3 years ago about mobile phones. And of course, if you played with something like this before, you start just throwing everything that you found on the old device on the next one. So I tried all the issues with Siemens phones on the Blackberries, and turns out the JUT description file thingy actually kills the browser on the Blackberry as well. The responsible code is Java, and latest news is it's probably not a buffer overflow, but something is really, really wrong there. Interestingly enough, you could switch tasks so the browser would go in background, but you could not kill the browser. There was no way to kill the browser. Hard reset really didn't work either, which is interesting because hard reset should actually, power cycle your CPU or something, which it didn't. So you actually have to take out all the batteries and everything else, and then wait a minute and then boot the device again. And it's fixed, by the way. Things to try. We've seen the pictures. I would be really interested in finding the JTAG connectors. For those of you who don't know, JTAG is actually a serial protocol for debugging on embedded devices. So it should be 4 connection points. Nobody played Bluetooth on the Blackberries so far. The only thing we have seen is turning Bluetooth repeatedly on and off crashes the device. This is actually, someone showed this here at the Congress to me. It was just great. The JVM is, invented by RIM and rewritten by RIM, so there is a high potential for bugs. Virtual machines are not easy to code correctly. Reversing images is always a good idea. Figure out checksums and everything that's, loading. And actually, Mark came up with the idea that loader.exe, the code should actually be able to read from the device as well, not just write to the device. Turns out he's right. The question is, can one actually use the code from the loader and make the loader read memory areas? It looks like that. So the interesting part about the whole BlackBerry story is the devices and everything is what you see. That's what you have in your hand. The way more interesting from a tech perspective, what you get is this. It's the BlackBerry Enterprise Server. Most people actually don't know it exists. The BlackBerry Enterprise Server is basically a box that at one point in time someone was bringing into the company, and the security administrator goes to the box and says, "What is it?" And I say, "It's a BAS." And he says, "What does it?" "Well, it connects to RIM straight out of the net." "Okay, so we put it in the outer DMZ." "Oh no, it needs to sit right next to your internal mail server." "No." And then the CEO comes and says, "Well, I want my BlackBerry to work." Yes. This is the BlackBerry Enterprise Server. Everyone hates it. So let's look at what this beast is. The later versions actually, due to security concerns, contain a router. Big name, little software. It's basically a TCP proxy. It talks TCP proxy and proxies SRP protocol from the inside to the outside, and runs on Windows. And we have here the big BlackBerry Enterprise Server with a dispatcher, then mobile data something, a alert service, a attachment service, and a policy service, and a lot more files. It's a pretty big piece of software. Here you have a connector sitting on either your nodes, exchange, or group-wise mail system, and talking directly to your Blackberry server. This is why they need to sit next to each other. And then you have a Microsoft SQL database that contains like all the interesting stuff. And yeah, we're going to detail that. So here's how much permissions this beast needs. So you get 3 accounts. You can easily combine them into one, is what the administrator guide says. It's obvious why. They all need lots of permissions, so it doesn't really matter. You need the permission to log on locally and log on as a service, which is cool. You need the permission to be a local system administrator. You need read-only administrative permissions on the Exchange and full administrative permissions on the Exchange Mail store. So that's a pretty powerful position, and therefore it's really interesting to look if you can abuse this position. The SQL database is actually installed by default with user authentication. It's running on Windows like everything in the enterprise server. I don't really get why they don't use internal authentication, because that makes a lot more sense, because you're running on a Windows account anyway, so you can use the built-in, a lot more secure mechanism. But they actually use user authentication, and yeah. No password. So it's basically just the user without the authentication part. We have tables for the individual messages and mails. They're just put into tables. But they also store all the keys in there. So if you have permission to connect to the SQL database because it sits right in the middle of your network, and you know how to enter no password, then you connect to your SQL server and basically do a table dump. And what you get is all the keys. You get the authentication key, you get the device keys, like the current, the last one, and the one that's supposed to go onto the device right now, which you, of course, can use to decrypt the traffic. And yeah, it's all in there. So when you see, this is the mysterious SRP authentication key that most people think is a software registration key thingy. So this is how it's shipped. This is how you need to transform it. You just take out the dashes, and then the entire algorithm to make it a usable key is you basically just left shift it. They only use 4 bits. It's called a 8 to 5-bit translation mechanism that comes up with 20 bytes out of 40. Okay, so if you transfer something from 8 to 5 bits and then get half of the data back, it's probably more like 8 to 4 bits, which it actually is. But the code says it's 5 bits. And then they have a mapping table that you easily find in a binary. Yeah. The beauty of updates. Like all the security people tell you, keep updating your stuff. Same with Blackberry servers. You get service packs, you get hotfixes. The release notes tend to be extremely entertaining. Things like, I created an appointment between me and someone else, and then a third person got a pop-up, or something like this. So you find extremely funny stuff in there. Hackers should actually update their BES as well. There are 2 reasons. First of all, news, there is something like bindiff, so you can take the update and see what's changed. And when the release note said, oh, we had this problem with the server crashing when someone had read a really long subject in the email, then you look at the update, look what's changed, and there's this condition, if subject longer than something, then drop email. And of course, the version before didn't have this condition, and here goes your exploit. The other cool thing is for reverse engineering, it's large binaries in C++. It's really not easy to reverse engineer, but you get free debug symbol files with the patches. So they ship the entire debug symbols with it, which is actually about 5 times as much as code they ship. Well, it's C++. And you actually get them in the updates, which means now you're not talking sub 4080 FE, but you're talking like SRP protocol decode. Really good. Code style and quality. Interesting because we're looking for failures of quality assurance or vulnerabilities. It's massive C++ code. It's by-the-book pattern implementation. So someone actually, took an entire university and hired them as coders. But it was a good university. They have really large classes, and they tend to write extremely large functions. It's mostly STL using code, so you don't find a lot of string copy and stuff in there. And it's fairly hard to reverse engineer until the first service pack because of the PDBs. It's surprisingly good. STL actually helps a lot. So when people actually have something like a real string class, they stop doing string copy because it's less convenient. They have a very conservative coding. So I was like checking the receive functions, and like the upper layer does a select, oh, there's a byte, calls a function, does a select, oh, there's a byte, calls a function, does it select, oh, there's a byte, let's receive it. So they really check often, but generally using signed integers, and the SRP issue that you've already seen is a typical signed integer issue. Interesting libraries they use. They actually use quite a lot of code from other people. So they use for Microsoft Office, they use the iStream classes, nothing better to do than that. For HTML rendering, they use the Microsoft thing, and they install MS XML SDK, and actually nobody knows why. It's installed, and you get a documentation on the desktop, but you can easily uninstall it, and it doesn't change anything. This company, Horizon, they're now RIM, so I think they got bought a while ago, and so this is now all RIM, but it's their former product. It's a central parsing engine for the attachments, and then they implemented PDF parsing and Corel WordPerfect parsing for the attachments. Interesting libraries, open source. Now we're getting into something really funny because the zlib is not really recent, and it's of course used to unzip files. Known bugs in a library that someone uses in a big product is always a good news. Graphics Magic is a spin-off from Image Magic, is a huge pile of code. It's for image parsing and writing and everything else what you know from Image Magic. Graphics Magic actually is a lot bigger than that. So I think the latest version is like 35, 40 megabytes of plain C code. And it's fully linked, including the debug code, so you can match 101. The same for the zlib, for example. You can match 101 what code they took. So the unzip code is actually unzip.c from the contrib directory of zlib. And you can sit with the binary and the source code and match it one-to-one. So with debug symbols, it's really easy to do the same for Graphics Magic. And this is what Graphics Magic supports. OK, how good are the chances that you can parse all those file formats correctly? Yeah, about that. So they actually don't openly support them. Openly support is something like PNG and TIFF. And what happens is you have this Arizon pre-parsing engine. It looks into the file, and it sees like GIF98A. And says, oh, cool, GIF file. And then puts it into this monster beast open source library and says, make a plain image out of it so I can send it back to the crackberries. And this thing gets it and then tries to figure out the format itself. Now the question is, can you make a combination where the identification says it's PNG, all you want is passed to the library, and then build an XBM file and exploit an issue in the XBM code. The changelogs of Graphics Magic, of course, when you identify a big open source library being used in the product you're just looking at, next thing you do is download everything, every version they ever had, and see where they came from, where they're going. The changelog is really interesting. It talks about like security patches. It talks about like possible stack overflows. This was really interesting. fix a Stack Overflow vulnerability is actually something that was found for ImageMagick. But I think that one here, this security patch here, involved removing about like 700 calls to sprintf. And if you import a large-ass library and you don't know what it's doing in your product, it's always a bad thing because it has its own format string mechanism for arbitrary text fields. So if you load an image using GraphicsMagick and the image comment or copyright or author or whatever you want was something like this and it got a %t in there, it will be changed in the image and replaced by the actual file name. And you got everything. You got like color, size, and stuff. Well, if you don't read the code you're linking to, you don't know this. And of course, no, you cannot easily parse everything correctly. It's actually, GraphicsMagick is actually really bad. So it takes about a day to find a arbitrary vulnerability. So you have an integer overflow in a TIFF parser. It allocates 0 amount of bytes and copies the image data over it. Making this slide was really easy. I basically had to replace TIFF with PNG because the conditions are not really the same, but like the vulnerability is the same, it's the same thing, everything is the same. Interesting enough is the PNG guys actually try to protect stupid coders from making mistakes by putting an arbitrary value, maximum value, for the width and height, because the most classical image parsing attack is width and height will be multiplied by each other to figure out how much space you need, how much memory you need. And if that's going to be over 4 billion, then it overflows, and then they allocate as much memory and then write stuff in there. So this is why they limit it arbitrarily. Of course, this means you have to read like 4 more lines of C code where he's multiplying it by 20, and then everything is good again. Yeah, I already mentioned it. There's a zlib museum living in a PNG parser. So we have a known decompression bug in the zlib version used. So the PNG image data is zlib compressed always by standard. There is no other way to do it. That, of course, means you get a heap overflow when decompressing image data. Interestingly enough, while using this huge-ass library and not caring anything about it, and using an old version and all, the PNG bugs that became known, the libpng was obviously handled by another guy because they were patched. So, putting this all together, how will an attack look like? Now, we have vulnerabilities that execute code on the attachment handling service. Of course, the point here is, often you get a question, but how, this is in the middle of the network, I don't get a shell back. Well, you don't want a shell back. I don't want a shell, I want the keys. So this is, for those of you who don't know, this is the international SK symbol for an asshole. Yeah, so news, there are assholes on the internet. And so one of them actually sends an email with an attachment to your arbitrary BlackBerry user account. Now, as soon as the user of the BlackBerry finds the attachment name interesting enough to click on it, we've heard that in other scenarios on other platforms before, this happens. So you basically execute code in this space. Now, you would never, I mean, if you spend so much time writing an exploit for it, you would never actually try to export a shell through 2 firewalls. It is possible, but it's like the most unstable thing to do. You basically own this box, and then you use the existing code of the enterprise server to do SQL queries on the server and query, yeah. Well, you do a remote database dump over SMTP, because then you use the other provided functions and talk to the connector and, give me the key. So this is the reason why you have to put this guy in jail. There's no other way to do it. You have to really take it off onto a separate box, which is supported, and then put a firewall in between, and make sure this guy doesn't talk to like secret server and your mail storage and everything else, because this guy here is 100% parsing code, which means 100% attack profile. The problem with doing this is that at the same time, it will, of course, need to talk to the Blackberry server. And to do this, they actually invented a new protocol, never been a smart idea, and use unauthenticated XML files over a TCP port to control this. Which means you can, of course, it's unauthenticated, it's XML. We all have text editors in Netcat. So you send queries over, you can query version, statistic, number of processes, but you can also set the processes, which is really interesting. What happens if you set the processes to 0? Due diligence, it turns off all the processes. No attachment conversation. 20,000, I never managed that. If you got a really, really big Windows box with lots of RAM, I would love to see if there is a limit on how much child processes one can have. So I got it to like 7,900 before it died. So here's the final administrative info, and we worked hard to have this here. The JUT issue, as I said, is fixed on the handhelds. The PNG issues are fixed. Actually, the code no longer uses graphics magic in this case. zlib is updated. The TIFF and the SRP issue we were talking about are pending. They're right now, well, yeah, there's not so much information on it. Okay, so we have this traditional final slide. Special thanks. Special thanks to a lot of people. I would like Ian to wave a hand. Ian is from RIM. He's their security guy. And thanks for being here. Yeah. Anything else? Let's get drunk.
See you next year.